Welcome to your CCPS Science Review Lab. Let's start off by taking a look at the image below and thinking about how it's related to light. Well, clearly we have a rainbow, and if you look kind of carefully, it seems like we have what we call a double rainbow. Did you know that this rainbow is a product of light? And technically, so is this double rainbow. But did you know that the double rainbow, the second one, is actually a reflection of the first rainbow? Well, where's my evidence for that? Have you ever looked in a mirror and noticed that everything in the mirror seems to be opposite? If you look very carefully at our double rainbow over here, the light colors are opposite. It's a reflection of the first rainbow. Today, though, I don't want to talk about reflections. I want to talk about refraction. Refraction is technically how we get this first rainbow. Let's take a closer look. When we're focusing on refraction, we're talking about how light is bent. Okay, in this image, we have a straw, and that straw is sitting in a glass of water. And even though in real life, this straw goes straight down to the bottom of this glass, to us, it looks like it's bent. I actually have a funny story about something like this. Once upon a time, I was out hiking with a group of friends, and we came upon a small stream. Now, we had never hiked this trail before. So as we were thinking about crossing the stream, I was a little hesitant. I was worried that the water might be too deep. But my friend looked down and was like, "Oh, it's fine here." And he proceeded to roll up his pant legs because he really thought that the water was just going to come up to maybe about his knee. As he took a step out, he was very surprised when in fact the water reached all the way up to his waist. Now, my friend's a pretty smart dude. What confused him about the depth of the water? It was actually because what he was looking at was a refraction of light that made the stream look much more shallow than it really was. Let's see what this is about, okay? We know that light travels in waves, okay? Now, as those waves move through substances that have different density, those waves move at different speeds. So we have light up here, if you look at my mouse, traveling through air. And when it's traveling through air, we can see that the straw is nice and straight over here. Well, as those light waves hit the water, they slow down, just the way you would. Imagine that you're running at the beach and then all of a sudden you hit that water. That water makes you move more slowly. The same thing happens to our light waves. So they bend. And when they bend, they create this illusion that the straw is actually bending. Or in my friend's case, that the water was more shallow than it actually was. So the idea of refraction is that light waves are bending due to the density of the substance that the light waves are moving through. Let's take a look at this picture. What evidence can we see of refraction here? Well, if we look up where light waves are moving through the air, the yellow looks like it's over here. But then it's scooched over to the side, over here, because those light waves are bending. The same goes with the blue. Kind of have a mixture of refraction and reflection going on. When we look at our spoon and we see that split, again, there are those light waves slowing down as they go through the water, refracting. So, as those light waves go through the water, they slow down and they bend. So we've got that bending and slowing. Those are the two words I want you to associate with the idea of refraction. Now, come over here and show me what you know. Go ahead and fill in the blanks. You've got your paragraphs and you've got a word bank. So in your notebook, looking at the container, the ruler, and the water, and thinking about light waves, go ahead and describe refraction for me. Good luck!